Hello, everyone. Welcome. This mic thing is really weird. I'm not used to mics. I just hear echoes everywhere. How does my voice sound? Awful? It's good? Great. Cool. Welcome to Facebook. Thank you all for coming out. I'm Tom Okino. This is Jordan Walk. So we're going to get started here, as long as everybody's all settled in. Does everybody have a beverage or whatever? Feel free to get up in the middle if you have to and get some more beverages and snacks. So again, I'm Tom Okino, and today we're going to talk a little bit about a JavaScript framework we built at Facebook called React. And the whole purpose of this framework, or the reason that it came about, is because there's a lot of internal discussion in various teams and everywhere else about how should we structure JavaScript applications. And more specifically, how should we structure JavaScript applications that run in a web browser? And there's a ton of different answers to this question. And some of them are up here on the screen, okay? There's a lot of JavaScript frameworks that try to answer that exact question. How should we structure our JavaScript applications? These frameworks have allowed us to kind of move forward as a platform. Like the web can actually now build real apps. Like you can build things that feel good now. Most of them, they have this consensus. The consensus is that MVC is the right way to do this, And it's not just MVC, right? It's, model view view model. And it's, as Angular calls it, it's model view whatever, right? But all of these architectures and frameworks have one thing in common, and that's models. Right? So models are the primary way that these applications they're at the heart of all of these different frameworks that I showed on that crazy slide, right? Typically, models in these frameworks, they're basically just observable objects, right? And an observable object has some events API that allows you to subscribe to changes on that object. Is this kind of familiar to everyone? We've all kind of seen this. Everybody's nodding their heads. Yes, you've all played with this, right? And basically what happens is developers set up these bidirectional data bindings that allow you to subscribe to changes on your model such that whenever something changes, you can mutate or update your view, right? So familiar concept, nothing new here. And this observable model pattern, it actually encourages mutation. Because what you do is you render something initially, and then as your data changes, you mutate the thing that you just rendered. And the key word there is mutation, right? But mutation is complex. And at Facebook, it's starting, it's got to be about two and a half years ago, maybe even more. Starting with our chat rewrite, we wanted to kind of make things simpler, right? We wanted to minimize the amount of mutation that developers had to deal with. So, let me show you what I mean by that. Here's the structure of a simple application, right? One thing you'll notice is that all updates in this entire system go through a single channel. They all flow in one direction. Let's call this one-directional data binding, right? All of these updates that come through this system, whether it's from user input, real-time updates from the server, the initial payload, the initial data that came in from the server, all those updates go through a single flow, and then they eventually get down to our views here. And this is the piece, as a front-end engineer, this is the piece that I care the most about, right? I care about the user experience and building the things that the user's actually looking at and touching. And the simplest way, conceptually, that we've found to build views, to build this piece, is to just basically avoid mutation altogether. And you're thinking to yourself, like, what? Wait, what? You need to update things, right? But instead, what we found is that if you could just, anytime your data changes, if we could just blow away our view and just re-render the thing from scratch, that would be so much easier, right? It would make your application, the structure of your application and the amount of code that you have to write, it just makes it so much simpler, right? Because you could describe what your view looks like and then never worry about updating it. It's just like, okay, when my data changes, I'll just blow it away and re-render it. But does that work? In the browser, it seems like that would be prohibitively expensive, right? That we all know the DOM is slow, and I feel like that's going to be really memory expensive and just slow. It's not going to be performant. And additionally, if the user's typing into a text box and then some comment changes right around that thing and you try and blow that away and re-render, it's like you're going to lose their state. Maybe there's some internal state that you're not even showing, you're not even displaying to the user, but you're going to blow all that away, right? So conceptually, we still want this model, though. From a developer standpoint, we want to be able to say, OK, anytime anything changes, we're just going to start over. We're just going to blow everything away and re-render from scratch. But we want to do it in a way that's actually performant and actually provides a good user experience, right? So the solution that we came up with internally is called React. And our tagline here is a JavaScript library for building user interfaces, because that's basically what it is. We want all the good parts of a complete re-render, that blowing it away thing I talked about, but without the downsides, which is basically the performance and some negative user experience side effects. Conceptually, your application can be a lot simpler because, again, we never need to worry about going from state A to B, or A to C, or B to D. You just worry about going from 0 to rendered, OK? At the heart of React are what we call declarative components, or just components for short. Again, and I'm going to harp on this, and Jordan will actually talk about this a bit as well, describe what your component looks like at any point in time, OK? This is more than a template, though. This isn't just, invoke some function that returns a string, and that's what my thing looks like. Because in that case, we would need to literally blow everything away and set the inner HTML of some node to be some new inner HTML. Components are actually reusable APIs that encapsulate a bunch of different stuff. It's the markup. It's what the thing looks like. It's how the thing functions. It's the behavior. It's the CSS, the JavaScript, how the thing is structured and everything. And it hides the implementation details from the clients, from the people who are actually using these components. So let me give a concrete example. We all know how to make an input in HTML. Well, if you know how to make an input in HTML. We should be able to make an interactive component like a type ahead, which is just an autocomplete search box, with the exact same type of code, right? Very declarative. I need a type ahead here, give it some attributes, describe how it works. And then, as a developer, I should be done. I shouldn't have to actually wire up events. I should be able to just drop this component into my page, and then it works. So, another feature of React is that we don't have any explicit data binding. So everyone nodded their heads earlier when I said, oh, you wire your view up to your model, and when things change, then you update your view. But in React, we don't have explicit data binding. Now, frameworks today are getting a lot better at this, and they have what's called declarative data binding. So if you're familiar with something like AngularJS, what's really nice there is you don't actually have to wire up your view to your model. You just say which properties of your model you want to use in your view, and then as the model changes, your view will be updated, which is really nice. But implementation-wise, behind the scenes, it's doing the exact same thing. It's doing this data binding where it manually or it automatically wires up your view to that model. And React doesn't use this. So if it doesn't use data binding, how does it work, right? So let's talk about two things. One, how are things initially rendered? And then two, how do updates happen? Because those are the two important pieces. So every framework, regardless of how the implementation works, they're going to provide you with some way to get your initial user experience onto the page. They're going to provide you with some way to generate markup or DOM nodes or whatever, inject that markup into the document, and then wire up your events, your interactive pieces that the user can kind of play with. In React, we just define one render function. And the purpose of this render function is, again, keep harping on this, to describe what your component looks like at any point in time. So this render function that you provide, it doesn't return a string. It returns a representation of your view. And what we do is, since components can compose other components, we recursively call render to build up this hierarchy, this recursive hierarchy, that is an exact description of your component at any point in time. So then, when we want to actually generate the markup for this thing for the first time, we take that representation, we iterate over it, we generate a string. It's a big string of markup. And then we inject that string into the document. What's really interesting about generating a string for this thing is that we do something called two-pass rendering. So what I mean by two-pass rendering is we generate that string, and then later, after that string is injected into the document, we attach the event handlers at the top level using event delegation. This has some really interesting, or exposes some really interesting possibilities. If you're generating your string completely separate from where you're hooking up your events, you can render on the server if you want. You can render in a web worker if you want. And we actually already built server-side rendering into React. The exact same code that we use to generate the client-side components can be run on the server, and string is generated. The user sees it immediately. Your events are hooked up as soon as JavaScript is ready, and then everything works. So that's just the initial render, though. Let's talk about how updates happen, because that's the more interesting piece, right? Anyone with any templating language can build that initial render and inject something that the user can see, and they can probably even do it on the server with compiled templates. But updates are the more interesting piece. We talked about not having data binding. So how does React actually update your views? Well, instead of mutation and instead of updates, we use a process we call reconciliation. And the purpose of reconciliation is to keep your UI up to date and fresh, as we say, as your data changes. It automatically updates your views and updates your DOM, your representation of your component, as your data changes. And you're all like, everyone's skeptical. If you're not skeptical, you're probably sleeping. It's just, that shouldn't work, right? That's a really hard problem. But if you remember that render function that we talked about that does the initial rendering, remember, it returns a representation of what our component looks like at that point in time. So this is pretty cool, because what we can do is we can call render and get a representation. And then when something changes, we can call render again and get another representation. And then we compare them. We literally, in JavaScript, compare what the two representations look like and find all the differences. So we compute this minimal set of differences from those two objects, and based on those differences, we batch up a bunch of DOM mutations and update your views in the minimum set of DOM mutations possible. So in order to show you what some of that code actually looks like, because this is kind of hand-wavy at this point, you should see it for real. I'm going to pass off to Jordan. He's going to actually show some code samples. Thanks. Yeah.
All right, so here's the simplest example of a React component. Is this mic on? Good. Here's the simplest example of a React component. In this case, we're instantiating a React component, and we're instantiating the simplest React component that ever exists, the div component. And we're injecting into that a span component. And so this is just the JavaScript API for React usage. And so all the attributes here that we pass a div, they mirror the attributes that you would use on HTML nodes. And the second argument here, separated by the comma, is a list of children that you're passing into the div. And we're passing that span in there. Span has no attributes, so it's set to null. But it does have a text child with hello world. And so to get this onto the page, we invoke React.render component, passing in that instance that we created. So this is a lightweight description, like Tama was saying, of the user experience. What's up?
Could the span child be like another React node, or does it have to be text? Or
Absolutely. It could be arbitrarily deeply nested component instances, and even higher level components like type ahead, and I'll get to that in a second. All right, so here in the center, like I was saying, we have these lightweight divs and spans. And if you pay attention to the API, React is a JavaScript-first paradigm. And there's a lot of reasons for that. Because JavaScript is powerful, it's flexible, it's a language you already know. And you're able to represent interactions and logic that are just really hard to do in other more constrained languages like templating syntaxes. And so a lot of other frameworks are kind of going along the same lines and letting you define your entire UI in JavaScript alone. And I think that's really powerful. But there's one thing about JavaScript that ends up kind of like getting in the way as you build these really, like you were saying, like deeply nested components. As you start paying attention to these braces here, and you see like 20 rows of like curlies. And you don't even know which one corresponds to the other one. Maybe you have to get some like Vim like syntax plugin that will match the colors. It ends up looking a lot like Lisp. And so what we did at Facebook is we addressed this problem by inventing a new syntax that's still every bit JavaScript, but it's a little more familiar to somebody that has experience with templates or HTML. And so like this is just a very lightweight transform that we apply at Facebook. And it's completely optional, and it's not intrinsic to React. If you were to look at the React source code and like look for how many references to this syntax there are, you would find 0 references to this syntax. But again, this is just compiling exactly into what you would otherwise write in JavaScript. So for the rest of the slides, though, I'm going to show it in what we're calling JSX syntax, just because it's more familiar to us. All right, so the real fun starts when you begin to define your own new composite components, your new higher level components that are consisting of lower level components like the divs and the span. So in this case, we can instantiate it just like we did the divs and the spans. In this one, it's called an action button. It has a text attribute and an on-action callback. So these aren't like div attributes, right? This is not class name. This is not on click. This is on action. There are our own synthetic events, their own synthetic properties that we interpret when we define the action button. All right, so let's start defining the action button. A few things here. You must call React.createClass, and this creates a new class that you can instantiate. It's like a JavaScript class. And you give it a set of methods that you want to provide to this new class. And like Tama was saying, you describe your component using the render function. So our job is just to implement this and describe what our view looks like. We start filling this out here. Oh, so you'll notice that once you define it, it's like a variable that's in scope, right? You can instantiate it, and that's all that this lightweight optional syntax does here. So if we start to stub this out, we're going to say that our action button is a button with a span and has some text in it. But we want to interpret the properties that are provided to us. We want to interpret this text. We want to place it inside of that innermost span. And so the way that we do that is we refer to these properties that are passed in via this.props. But it doesn't just have to be strings, right? You can pass anything you want because this is a JavaScript first paradigm. That means that you can pass function handlers in for on action, and you can refer to it the same way that you would refer to strings. And so the buttons on click is our action buttons on action. And it might help you to just kind of think of this as like a way to route this data into the implementation of your component. And so you see these arrows here saying, I'm going to stick the text inside of the span and the handler inside of the on click of the button. But React is more than just about routing. So you can perform any transformation you want on this data because this is just JavaScript, right? So you can to uppercase it, you can slice it, you can reverse it, you can do anything you want. So they're actually really highly powerful transforms. But one thing that may not be clear here that Tom did allude to was that your render function describes your UI at any point in time. So that means that if your text were to change or your function handler were to change, we would figure out the minimal set of DOM mutations needed to carry out that effect. So if your text were to change from book flight to give talk, we would find the span that is affected by that text and only flip the inner text of that span. We wouldn't touch the surrounding div or the surrounding button in the DOM at all. Okay. All right, so and the real fun starts when you start building even higher level components that are composed of these other higher level components. You can start building up your entire app by stacking abstractions on each other. And you get that same reactivity, that same sort of minimal set of DOM mutations flowing throughout large sets of your application. And so if we wanted to find a counter, it already starts to sound a little bit different because it's clearly more higher level. But we still have the same render function. We still have the same React.create class that we had before, but there's something a little bit different here. And again, we're using the action button that we defined before. We had a text and an on-action callback. So this counter is going to have a div. It's going to display the count, and we're going to have two buttons that we previously defined to increment and decrement the count. It's the simplest example ever. And whenever the on action is invoked, we're going to call our member method add to count, passing in 1 or -1 depending on which button you clicked. Okay, but there's something different here, and that is that we have this special method called getInitialState. And so a counter has state, right? So with other templating solutions, it's really hard to model state with these things. And a lot of times it's not a good idea to model state inside of a template, but sometimes it is. Sometimes this internal state is a concern of your reusable component. So if you want your component to be able to sort of take the role of a state machine, you need what every state machine has, and that's an initial state. And so getInitialState allows you to define that initial state. We're going to say the count is equal to whatever you specified as your initial count in the properties. Okay, so in the same way that we could represent render as a function of arbitrary properties, we can represent render as a function of arbitrary state. So anytime that our state changes, just like anytime that our properties changed, we'll still figure out the minimal set of DOM mutations and only serialize that over to the DOM bridge and only apply those mutations. And you can see that the way that you would modify your own internal state, which are different than properties, is you would just execute the set state method. So what that'll do in this case is it'll set your count to be equal to your current count plus the delta that was supplied. If that's clear. All right, so anybody showing you a framework is going to show you the most contrived examples ever. But there's always a way to break out with React. There's a way to break out of the paradigm. And that's really important for somebody like Facebook who's got a very established product with a lot of different technical solutions kind of like munched together. We need a way to be able to break out of the reactive paradigm and tap into existing frameworks, existing markup, existing places on the DOM that weren't rendered using this framework. So we have all sorts of ways to do that. You should check them out. And one thing that you can do is you can like call out your backbone models if that's what you're into, and subscribe to those events and let that inform Reactive that it needs to update an internal state or something. Place well with others. Yeah, totally. There's some really good examples online of like people integrating with either Angular or with Backbone. But yeah, give it a shot. All right, so Thomas is going to talk a little bit about how we got here and where we want to go with React.
I don't think so. Oh, there we go. OK. So more on that escape hatch, though. This is actually pretty interesting because just yesterday, this guy, Pete Hunt, who works on Instagram, he built something that allows you to basically use Angular directives from React. So you subscribe to this one little event, and you basically just say, OK, React.render component. And it allows you to define your component in React and then use it inside of Angular. So this is a really important piece of React, is this interoperability. When we were building the UFI, I mean, this is on my story time slide. When we were building what we call the UFI, which is our comments and likes and everything on Facebook.com, we needed to integrate with a lot of legacy stuff. I mean, first of all, newsfeed is all rendered on the server. So if we wanted to render all the comments on the client side, first of all, we need some way to interact with like existing DOM, like some existing document. But also, like, we needed the way to take our server rendered components, like the text box that you type into. We needed to be able to embed that inside of this React view, right? So React gave us this like great escape hatch. It's just like, hey, here's your DOM node. Do whatever you want with it. And then we were able to actually hook in and instantiate other different legacy components and things like that. So that escape hatch is actually really, really important. Tons of stuff on Facebook is now built on top of this stuff. And like I said, comments and likes, anything on Facebook.com that uses that kind of light blue box where you like something or type in a comment, that's all built on React. On our mobile site, actually, the side nav, the bookmarks are all built on React now as well. Props to John Watson back there. So this works on mobile really well. We're using this everywhere. We use this for all of our ads interfaces are being built on top of React now. But more interestingly is Instagram. So when Instagram joined Facebook about a year ago, I think it was about a year ago, they wanted to build, one of their first projects was they wanted to build Instagram on the web. They wanted to build Instagram.com. And they had some stuff up there, but it was very, very light, right? It was just the permalink pages for photos, so you could basically like view them in a web browser. But they wanted to build like a real feed and real profiles. And so they started building it, and they were using like traditional solutions, things that existed, some client-side MVC. But then a few people started looking into like how we did things at Facebook, and they were like, wow, like this React thing is pretty cool. We want to try and use that. So they came to talk to product infrastructure. They came to talk to me and Jordan. They're like, hey, we kind of want to use that thing over on Instagram.com. And we're like, man, your stuff is on Amazon Web Services. We have all this like proprietary front-end infrastructure that like bundles and packages our static resources and ships things down the wire. I'm like, I don't know. I don't think it's going to be possible. But they really wanted to do it, and we saw utility in doing that. So what we did is we kind of tried to divorce it from our infrastructure. We tried to build it in such a way that you could basically just take React and some tooling and use it anywhere. And in the process of using Instagram as kind of an external client, we set up for Instagram.com to be built completely on React. So if you go to Instagram, the entire thing on mobile, on desktop, everything, it's a responsive site. It's all built using React. And the initial version of this integrated with backbone models. They basically said, OK, as our backbone models change, we're going to tell React to re-render. But as they wrote more and more of their views using React, they found that they just started deleting their models. Their code just got smaller and simpler, and their application became very declarative. It's like, this is what Instagram.com looks like. And that was pretty exciting. So after about 18 months of using React internally, some people started to say, man, we should probably start sharing this externally because no one's doing it this way. So that's when we got the idea to kind of try and open source this thing. And so if you know Facebook, historically we haven't really open sourced much front end stuff. We open source a ton of back end stuff, especially our PHP compiling, our hip hop engine, and a bunch of other stuff. But we haven't really done much with JavaScript. So we decided we wanted to open source this thing, and we actually did that about 3 weeks ago. So React is on GitHub now, and you can go to facebook.github.io/React and read all about it. And this was really great because this kind of acted as a forcing function for us to get really thorough documentation and examples, and to set everything up so that you can kind of get up and running very quickly. Jordan and I and a bunch of other people hang out in pound React.js on Freenode pretty much every day, all the time. So we encourage you to kind of hop into there and ask questions. Play with this stuff. We want to know what you think. We're pretty humble about this. This is actually just something that works for us. We're excited about it and we're passionate about it, but obviously we're not going to force it on anyone. Let us know what you think. We want to know, if this works for other people and if this, development model is easier. And we're really interested to see what people build on top of this and what comes next. So with that, thank you. That's all we have for the presentation portion. But now's the fun part, because now we want to answer all your questions, especially from those of you who are skeptical that this would actually ever work. So thank you. Cool. Yeah, I think we have handheld mics so that because I think we're recording it, right? Yeah. I'll walk around. Yeah. Question? Yeah. Go ahead.
Well, just so things like animations. Do you, when you kind of generate this difference of the initial state or the previous state and the current state, are you doing that on every single frame of an animation, or? And
No.
If so,
No.
So how do you handle that? Yeah.
Yeah, so that's a great question, actually. So for things like animations, it really depends on what type of animation you're doing. If you're doing an animation that can simply be described as adding a class name, so you're changing the appearance of something and maybe changing its state, maybe you're changing the color of something or you're bouncing an icon, those can be done very, very easily in here by just adding a class name, right? But there are more complex animations where you want to kind of animate something into or out of the document, right? So maybe you remove a comment and then that thing slides out. So what you'd do in that case is you'd say, hey, as soon as the user interacts with this thing to remove it, we're going to break out of React, we're going to have a DOM node. And then you can animate that DOM node however you want. And whenever you're done with that thing, you say, OK, go ahead, React. And then React will pick back up and reconcile the same way. We're going to work on adding better hooks for this, though, because it would be much better, it would be much more fun, in my opinion, to describe your animations in a declarative way rather than imperatively writing code to do that. But right now, it's just JavaScript. So it's very, very easy to just hook into your existing animation framework and do the same way you've always done it.
So is it possible, that's when you pull that DOM out of the React, awareness or whatever, is it possible that another event could come in that could kind of that could sort of override that awareness? Or if a server event comes in from an Ajax call or something, could that kind of blow that away? Or is it pretty much React just knows as a framework that this thing's no longer?
Yeah.
So I don't think that React adds any additional complexity to that, because that can happen anytime you do animations in any solution, really, right? So I guess right now the focus is on making the reactive paradigm really solid and removing all of those complexities. And then if you want to do the types of very hard to do animations are hard. We don't have solutions to particularly address those challenges yet. But I'm really interested to see if we can do this in a declarative way. I bet you could solve a lot of these problems. So if you have good ideas about how to morph between different states in a really cool way, feel free to try it out and make an extension and share it with the community.
Yeah, what's interesting about the way that components are rendered is we have this thing internally called Lifecycle. So you always know which part of the the rendering cycle you're in. Like, are you, did you just get mounted into the document? Are you in the process of updating? And you can kind of like, from your internal components perspective, you can kind of like tap into that and say like, oh, am I currently rendering? If so, like don't try and re-render something else, or don't try and do this. So it provides you with all the hooks you need to make that like better and easier. And this is actually something that's on our roadmap. Is like we want to make like an awesome way to do like animations between state transitions.
Yeah, that's a really good question.
Cool, great question. Yeah, yeah, man.
Hey, so my question is regarding the performance of this thing.
Yeah.
Since you told that you're literally comparing the whole DOM structure tree,
Yeah.
so my guess from over the head is that probably it's going to do well on a flatter structure, but as the components are nested more and more and more,
Yeah.
tree gets deeper, there would be a problem.
Absolutely.
So have you done any benchmarks or any memory performance comparison?
Yeah, absolutely. Great question. I'm going to start off by giving you an anecdote, and then I'm going to pass it to Jordan if he wants to talk a little bit more. But this is pretty great. When Jordan first introduced this to me, I was just like, nope, that's not going to work. Right? I'm like, no, just like, I have things to do. We don't have time for this, right? As it turns out, the thing that I didn't really understand is JavaScript is so fast. The DOM is what's slow. And actually, more specifically, reading from and then writing to the DOM and causing reflows and repaints is what's really slow. But JavaScript, man, it's blowing me away right now. It's so fast. We found that you can compare very, very deeply nested structures, all of the Facebook.com homepage, from one pass to the next in milliseconds. It's crazy. Memory is a very interesting issue because you'd assume that once you're building up this big object, right, that thing takes a lot of space in memory, and you need to compare another one, and then you're iterating, and so you have two of these things in memory. So memory is a very real concern. And we all know, like, if you want to make it more performant, just throw more memory at it, right? You can store more stuff in memory. But what's really nice about React is it gives you the ability to kind of do something better than the reconciler does by default. Because you know more about the state of your application than the internal system does. Because it's built in a generic way, right? But yeah, I mean, do you want to talk anything about that?
Yeah, sure. So just reiterating how important that escape hatch is. One of the things that you can break out of the reactive paradigm with is the ability to guide the system along as it searches out these changes. So if you were to look at like how much physical space is searched out on that page, you'll see like large regions, not always the whole page, but large regions. And you'll notice that like, oh, we're traversing like this much space. But the truth is that like a large percentage of this code is actually, of this traversal is defined in this much code. So if you can just go into your bottlenecks, identify them, and help guide the system along, you can make that a lot faster. And that's actually what we did with the comment pagination. We saw like upwards of maybe 5 times improvement in performance by adding 6 lines of code that helped guide it along. It's like, oh, I know nothing changed in this region for this type of component. So every time it encounters that component, it just like bails out instantly if nothing changed, which 98% of the time plus, nothing changed. Yeah.
Yeah, without knowing too much about Rails, I'm going to kind of compare this a little bit to Rails and ActiveRecord. It's very easy to get up and running, and it's so, like, you can develop and iterate so quickly. And then at the end, you kind of like profile your app and you look at everything and you're like, okay, now I need to go like improve and tweak and modify this piece. What we found is 99, I don't know, I make up numbers, 60% of statistics are made up on the spot, but 99% of the time, like what it's doing by default is actually good enough. And then only when you're doing something that's like kind of, we haven't dealt with before or it doesn't really know about, then you can kind of do this, like you get this hook, you're like, all right, you're about to update, what do you want to do? And then those hooks allow you to kind of really make it blazing fast and optimize memory.
If anybody wants to see a mobile scrolling demo after this, come find me and it might convince you.
Yeah. More questions? What else do you want to talk about? Yeah, go ahead.
You mentioned something about subscribing to event changes or something like that. How does that work?
So when I was talking about models, yeah, so the way that most MVC frameworks are set up is a model is a, man, it's just such a conflated word. It means so many things, but all a model is it's a JavaScript object, okay? And the thing that a model is different, the way that a model is different from an object is it allows you to know when something is changed, right? So if you have a backbone model, the interesting piece is not the data, it's when the data changes. So let's say in your model, you have something called a title and something called a subtitle, right? You're only interested in when the title actually changes. So you have an object that stores your title and your subtitle, and then your view says, okay, when the title changes, I'm going to set the inner text of this node to be this new title. And as a developer, you have to kind of manually wire that up. You have to say, okay, here's my model. I have a thing. And when the title of this thing changes, I'm going to change my inner text to this new inner text. A better example is like, let's say you have a button that represents some state of your UI. And that button is green when everything is good, but it's red when you have some invalid data, right? So the user types in some invalid data and your button turns red. In order to make that button actually turn red, you had to say, okay, when my model that's modeling all my data changes to invalid, update the class name on my button to be invalid. And when my model changes such that all of the data is valid, update it to be valid. And then in CSS, you make it green or red, and you disable some JavaScript functionality. So subscribing to events is basically just talking about that relationship between your view and your model. Does that make sense? More or less, kind of? So how do you get the information into the model?
If using it with React or outside of React.
In general, the information can come from anywhere, right? Maybe it comes from user input, and you've subscribed to some add event listener here. Maybe it comes from the server. Some data comes from the server and tells your model, oh, your new data is this. So you've changed now, and you need to inform your views. So that's, it's a bunch of different ways. It's basically anything that can change your application, anything that can change your internal state.
Usually through like a setter. Somebody
called
models
set.
have like a set method, and then it fires anybody who's ever subscribed to any of the fields that it detected a change in.
Set title, for example. Somebody would call set title, and then your view updates. Yeah, over here.
How does React handle getting user input out? You showed a lot of examples of data coming in. What does data going out look like?
That's a really good question. That's a really good question. Unidirectional data flow like this, like inputs are kind of inherently bidirectional. And
not kind of, they are bidirectional, yeah.
Sure. Yeah, you can think of them as bidirectional. I think there's also some complexities that come with treating them that way, though. Like, for example, you may want to reject a user input, right? And so if you have a unidirectional flow and there's always some higher level authority that can interpret that request to change and either accept it or reject it, then you simply update your internal state at a higher level and flush it down, or you don't update your state at all. And that's that's how we wedge it into the unidirectional flow. You can also use bidirectional bindings if you set them up manually, like Tama was saying, Backbone's primary abstraction is. So you can do that.
Yeah. So,
but we don't have a ton of great boilerplate that does this for you. We have examples.
Yeah, there's a bunch of different ways to do this.
You can have a change event on the text input DOM node, right? So whenever somebody changes it, you can go update some higher level piece of state, and it flushes back down.
So most of the time you're passing change handlers down, and then when the input changes, the top level change handler will fire, and then the whole thing will go down. And then what events do you guys actually watch for to trigger when you need to go recheck all of the render strings or whatever it is?
So that's up to you. I mean, you listen to whatever events you want. And often those events, sometimes those events happen from your views, like the user touches something, and so then you need to go back and update your state. But oftentimes they come from the server, right? Like the server just says, hey, I have new comments. Here's your new data. It pumps it into the top level at that React.render component. Here's all your new comments, along with the old comments, right? And then the system kind of figures out what needs to be put in there. So it's up to you and however complex your application is. Going back to the input thing, if you think about the way that a touch screen works, for example, the touch event doesn't actually get sent to the application that's on the screen first, right? First, the kernel handles it, right? The lowest level of the system handles it, and then it figures out, based on coordinates, what's at that coordinate. Is there an application there or a dialog or something like that? And that event is passed through the system. So when you're building something based on user input and based on events, the events come from the top, or in this case, the lowest level, and then they are propagated through. And if you think about the way that we currently handle validating user input, what happens is something like this. You'll type into a text box, and let's say we have some maximum length on that text box. The user types a character, the character gets inserted, some JavaScript event is invoked. It says, oh, the length is too long now, and then it removes the character. So you get this kind of flicker. But when you do things from the top down, pretend that as you're typing into a text box, the input is not responding directly to the user input at all. The system is just getting the events in and then deciding if they're relevant or not. And so then it propagates down like, oh, the value is now this. It sends it through. And in that case, if you have a maximum length, your system knows about it higher in the document. It knows about it higher in the hierarchy. And it prevents the value from ever being updated. So there's no flicker, right? So we're working on building into React like better ways for managing that. And that's basically just like on-change events and things like that. Yeah. Cool. Another question? I think there's a mic coming.
Hi. So what's on your roadmap?
Great question. A bunch of different stuff. So we have an internal wiki page that we're going to actually make external soon. The first thing we want to do, or the thing that we're working on right now that's coming into the next version, is making the event system like awesome. So the events that are passed into your like click handlers, in Jordan's examples, you saw things like onClick equals some function. The event object that's passed into that thing is going to be this like amazing, it's already an abstract event that gives you access to the real browser event, but it has all these nice properties of like smoothing out all the browser inconsistencies. But like the thing that's just got checked in today, that will be out within the next week or two, mimics the browser's, the W3C spec for how events should work, including the real hierarchy. So on a keyboard event, you have a synthetic keyboard event that extends a synthetic UI event that extends a synthetic event. And it has all of the properties that you'd come to expect from that documentation, but even in IE, right? So usually you have to use like source element or target, but now you just use target because that event object like looks like a real object. So that's one thing that's coming that's really exciting. Another thing is better management of children. So right now, the way that children are handled is they're basically just a prop. They're a property that's passed into your component, and they get reconciled the same way that your title and your on action and all that stuff gets reconciled. And we want to make it a little bit more explicit and kind of be able to describe that a little bit better. Anything else on the roadmap that you can think of?
No, that's it.
Yeah, those are two big ones that are coming in 0.4. We have bigger plans. There's like a lot more stuff. Oh, and then the other thing that's coming in 0.4 is very well-defined and hardened APIs for server-side rendering. Yeah.
And what's your future adaptation look like inside Facebook?
I don't know yet. It's just we're just going to keep iterating and keep adding. As we add more and more clients, we're finding different use cases. So the first use case for React, or the first use cases, they were pretty consumption-oriented. So basically, you're just viewing stuff. They weren't really interactive. They were kind of like, hey, we have some stuff we want to present to the user, and it's going to change over time. So let's do that in a good way. And we got that down, and we're pretty happy with that. The thing that we're working on now is interactive interfaces. So how does, when the user's typing into something or selecting checkboxes and stuff, we're working on that. I think our internal adaptation, you'll see it as it's happening. We're developing completely in the open now on GitHub. So I don't know yet. Yeah. There's a mic back there.
I was curious to know whether you guys have experimented recording events and replaying them for debugging or studying user behaviors.
Can you repeat the question?
If you guys have persisted and recorded events to replay them as a developer to debug something or generate reports for analyzing user behavior or anything like that. Are basically events replayable? Could I record them and replay them as a tape?
Yes.
The answer is yes, we have.
Yes and yes. But building that bridge was like 10 lines of code because everything in React is synthetic, right? The events are fake, like the DOM is fake, and that means you have total control. You can tap into that stream anywhere and do anything you want, basically. And so the two experiments I've done so far were recording the events on the way in and then replaying them back when maybe storing them in local storage first so that when you reload the page with like a question mark replay, right, it does everything the user did the first time. And then the other one is recording the DOM output, so the side effects of all the events. And you can do one or the other, and you can kind of it's two different ways to look at replaying it. So when you record the DOM mutations, that layer where we reconcile all the differences and find all the minimal set of DOM mutations, you just put a little recorder right there. And then you play it back, stream it to the DOM, and that's a really good way to measure where your DOM performance bottlenecks are and which CSS operations are triggering reflows because you have no other JavaScript running except for this really tiny loop that just replays back what it recorded the previous time. So there's a lot of cool things. You guys should just like go nuts and check it out and build extensions that do this cool stuff.
Oh, I just had a quick question, which was, what's the footprint of React?
Compressed and minified and gzipped, I think it's like 13K or.
Well, so right now, like we have some
gotta be
like
bigger than
error
that.
messages
That
that are in
sounds
strings, and like internally, we actually have this build process that goes and like strips all those out and replaces them with a line number, so that when you debug, you get this nice error message, but in production, you just get like an error code. That's huge on saving bytes. We're not doing that for the open source package, so right now it's probably around 18K. If you do that, and we'll give you guys the transform, you could probably get it down to about 15. And there's no reason why it couldn't get down to about 13 if we tried hard.
And also, the interesting thing about the core is that it's all closure compiler advanced mode compatible. So you can actually get down to like significantly smaller. We don't do that internally because like we have a single process that we use for everything, but like you can even make it smaller. It's actually pretty surprising how small this is, because if you look at the way that reconciliation works, it's like pretty explicit, and like you'll look through the code and you'll kind of understand what's going on. And it looks like it should be more, but it's actually pretty small. Yes.
Question was, is it entirely in JavaScript? Yes.
Which makes it approachable to me, because I don't like other languages. Yeah.
First of all,
sorry, 1 second.
really nice work. It's good seeing that. So I was wondering, how do you guys describe your own models internally? And are you going to open source that?
So this may be hard to believe. We don't have them. We don't have models internally. So for example, the UFI is represented, the model for that thing is a JavaScript object called UFI payload. And it's literally just a JavaScript object with keys and values. We don't have models. And this is like, I mean, I'll harp on the Instagram thing again. They originally built the whole first version of their site, or they started building it, using like Backbone and Handlebars or Mustache templates. And like as they started converting their views to React, they found that like, oh, your models kind of do less and less. But as they converted more and more of their views and they needed to wire up things less and less because things were just hierarchical now, they literally deleted all of their Backbone models. Like they don't have them anymore. But it's useful in that transitionary period when you're kind of like converting things. Like React provides you with a way to actually like subscribe to your Backbone model changes and then say re-render, from here down. But yeah, we don't have models. How do we structure our data though is a very good question, right? Because you can't just have a big JavaScript object sitting there, right? We'll probably talk about that at length in the future, but we call the system Flux. Basically, the way that it works is you have these centralized stores. So for example, for users or friends or whatever, you'd have a centralized store that represents those users. And basically it maps, it's just a way to get data about a user given an ID. And it's always kept up to date. And then components can kind of ask the store for data at the very, very top level. And then when you ask the store for data, if it doesn't have it, it fetches it. And then it invokes your callback after it gets it. So it centralizes your validation logic, it centralizes your update logic in one place rather than having a bunch of different models that can be mutated from all over the app. Make sense?
Yeah.
Yeah, cool. Yeah, go ahead.
I was wondering if you compared this, or what made you decide to do this style versus like something maybe like what Ember.js or Angular is doing with a big like run loop type of thing where they do their comparisons by looping a lot. It sounds like you're doing all callbacks and kind of hijack the DOM into your framework. I was wondering, like, are there performance gains with that versus those other things, or did you do any kind of comparison?
Yeah, I think it's more about trade-offs. Like, where do you see performance losses, and where do you see performance wins, and where do you see development wins and development losses? And so I've done a lot of work with the more Ember style, like observable models. And what I found there was that you actually end up creating all these derived properties. So you might have a user model record where you have a name and an age. And you have like a text input or you have some display that shows something that's a result of both of those fields. So you perform some logic to kind of combine them to concatenate them or something. And what happens is anytime anything in your models change, you end up needing to re-render a lot of things, right? And so as your application becomes more and more nuanced and more complex, and you have like real business logic inside of your views, or controlling your views at least, you end up needing to rematerialize a large percentage of the system when any small thing changes. So what React did, or the kind of insight there, was let's just cut to the chase and acknowledge that at the end of the day, we're probably going to be doing this anyway. Let's optimize the system for that. Let's make sure that when this happens, we don't have a lot of read-write patterns, and instead we have like large flushes that tend to do lots of writes, and then maybe one small read, lots of writes. And so like that pattern is actually really well, it performs really well in the DOM. Is that good?
An interesting thing about the way that models work as well is like multiple views can subscribe to the changes on that model. And then since the relationship is bidirectional, when your view updates your model and says like, oh, set the title to something new, the model needs to know which view that message came from, or else the model is going to inform the view that changed it that something has changed. So you need to build like pretty complicated systems to prevent like infinite, there's like graph theory about, I don't understand how that shit works. But it's so complicated, right? And so doing this like unidirectional thing, it kind of really simplifies that flow, because it's like, oh, an update happened, pump it into the top. Another update happened, pump it into the top. And I'm not really familiar with like, Angular run loops, but the way that I would kind of compare React is it's almost like immediate mode rendering. So the way that games work is like they don't worry about mutating what's on the screen to the next thing. They just worry about rendering all the pixels, right? So what we want as application developers is just say, all right, just render all the pixels. And then once you're done, once we have a new thing, something has changed, just render them all again. So as a developer, that's like what you conceptually think of. That didn't answer your question at all. Hopefully he did, but like I just like to riff on that. Cool. Yeah. Yes. One sec. Mike. Thank you.
So rendering the whole thing again may cause reflows and all that stuff. And Firefox and the Chrome guys are pushing their efforts to actually show you that you are doing some reflow. Avoid it, avoid it, avoid it.
Yep.
So from what I see is that you pour the water at the top and it funnels down all the way to the bottom. It's a reflow from top to bottom, what I see. I'm still curious about
So remember, we're not actually touching the document.
Okay.
When you pump data into the top of the system, we're getting just a JavaScript object. We're getting just a JavaScript representation of what the view should look like, right? So it's actually not performing a reflow from top to bottom. It's performing a, hey, what does everything look like? Give me that back, right? And the JavaScript object that, it's the JavaScript structure that represents that is then used to compute DOM mutations. And what's interesting is they happen at once. So if you want to change 5 parts of your view hierarchy, they happen in a single event loop. And by event loop, I mean we've computed everything that needs to change, and then we change it all at once, rather than changing one thing and then reading another property and then changing another thing. And that's what gets expensive. Does that make sense? Maybe Jordan can explain
I would have
better.
to look into the code.
Yeah, definitely. Please do.
Like there's browser reflows, and then there's like our system React reflows, and like these tend to be not quite as expensive as the DOM ones, and they end up helping you prevent a lot of DOM reflows. So it's a trade-off, and at least we have these hooks in here where you can optimize away these system React reflows, where you don't exactly have those kind of hooks in the real DOM, right?
Yep. Yeah, questions? One sec. I'll cover that in a sec. Yeah, for sure. Try again. No.
Hello?
Hey.
Okay, so I think what you're basically saying is you don't actually manipulate the DOM until you for sure know exactly what's manipulating. But how about queuing? So let's say 10 changes happen in a matter of milliseconds of each other. How is it processing and then processes again and processes again and then manipulates the DOM after each process? And then in that case, if it's happening very, very, very quickly, does it change the DOM very, very, very quickly as well? And all of this is happening near instantaneous, or kind of what's your queuing system for quick changes? So if 10 people are modifying the same page, and how does it reflow, or how does your system know to reflow what those 10 people have changed?
So we need a better system for queuing, but that's kind of considered an implementation detail of the system. And so we can, over time, optimize that and make sure that things get batched up most efficiently. Right now, we will compute the minimal set of mutations, so the smallest size. But there's a ton of interesting things we can do to make sure they're queued at exactly the right times, to make sure that they're maybe in a request animation frame if you're in some sort of video game environment.
Yeah, you could very easily debounce your React.render component call, and it should probably do this internally, such that if 15 calls come in at the same time, the only state that you care about is the most recent one, right?
Yeah.
And you can basically throw away every other update that came in because your state will be represented, your entire view hierarchy will be represented by the most recent one that came in. But yeah, all you need to do is basically wherever you output React.render component, you just wrap that in a debounce.
Or update state.
Or your internal calls to set state. And yeah, I mean, we can build that into the framework too, and it even provides you hooks if you wanted to do that just for your app. But yeah, you can debounce or you can throttle. Oh, a debounce means if a lot of events are happening, you wait until they stop, and then you execute, right? So if you were scrolling the page, you wait until the user stops scrolling, and then you update the layout.
I definitely think it's much more of a concern in the observable model paradigm where everything is an event that happens, right? Yeah. And so you have thousands of these things occurring, batching and queuing is hugely important, whereas with React, a few events happen and then potentially large amounts of changes occur as a result of that. So it's naturally batched kind of intrinsically, and then there's some more things we could do for queuing.
And we do this in Facebook comments. We batch the updates such that when all the updates come in, after they're done and they settle down, then we pipe them out to the screen.
Just as a little, that's what the run loop thing was solving for those people.
Right.
They would just aggregate things until the loop goes.
Right. Yeah, so that's what the run loop kind of paradigm solves. More questions?
We talk more.
Yeah, go ahead.
Is it on?
Yeah.
Okay. When you're trying to figure out what the smallest DOM mutation possible is, are you also checking text node versus inner HTML versus outer HTML, things like that?
Yeah, for sure.
Yeah, so in a list, one kind of interesting thing that happens is if in a list of components, we didn't show it here, but you can map over arrays and generate large evolving lists of structures too. And that's when it gets really fun. But if we notice that you have 10 adjacent new rows in your unordered list, we'll even compute all the markup of these adjacent new children together and concatenate it into one giant string. So that effectively is one inner HTML for only the adjacent regions that happen to be contiguous. So we even go as far as to do that. And then if you only modified one class name, we'll only flip that DOM node's class name.
Yeah, that's what I was going to say. Yeah, up here. Right behind you.
So is there any third-party library dependencies, or is it completely self-contained?
Currently, it's completely self-contained, yeah. For our build tools and stuff, we have some third-party stuff, but basically, React is just.
Did you run into any pain points in terms of not choosing something like jQuery or MooTools, or for doing DOM stuff? Where you felt I wish we'd required something else rather than having to kind of rebuild some of that stuff by yourselves?
Yeah, not really. I mean, from my standpoint, the only things that we do are those touching those DOM pieces, and jQuery itself is pretty big. I think it's somewhere around, I don't know, somewhere upwards of 10K, right?
Bigger.
I think it's 20K.
30 or 40.
Okay, it's 30 or 40K, right? And we didn't want to pay the cost of any other library. And there's actually really, really small libraries that do DOM manipulation and stuff. But what we found is we don't need all of it. We only need a very, very small piece of it. We're updating attributes on nodes, and we're updating text content or inner text, or we're updating class names. We really don't need all the power of a full library to do that stuff. The one thing we might do over time is implement or use Lodash or something for our merge functions, Lodash or underscore if you're familiar with that. Because we have all these utility functions that are basically the same thing that are in those libraries. But again, we don't want to pay the whole cost of underscore, for example, because we don't need 90% of it. So what we're waiting for on that is John David Dalton's actually working on splitting Lodash into modules that will every single function inside of that library will be a separate module that you can require, and it intelligently pulls in its dependencies. Once it works that way, we'll probably use it. But again, I mean, if the whole library is 13K, we can't see pulling in 30K for utilities or DOM manipulation, things like that. This is pretty bare bones. Yeah, behind you.
Hi. So my question is around the same thing that you said, that we are basically doing the comparison of two states to realize what has changed, right? So the thought in my mind was that, for example, if I have a page, for example, like Facebook.com, so when you are scrolling through the page, it becomes bigger and bigger and bigger, so the state is getting bigger and bigger, right? So the cost of keeping that bigger state in the memory, wouldn't that slow down?
Yeah, I mean, the way that Facebook is structured right now is every comment box, every like UFI, for example, is its own little client-side app. So for each comment box, we store all that stuff in memory. So this is more expensive than just storing the state in the DOM, because obviously we need to have both. But this is like negligible compared to the size of all of the things that we have on Facebook, right? Like the entire representation, in-memory representation of JavaScript is less in kilobytes than a single rendered photo, right? So the fact that browsers are already handling tons and tons of data, and like even on mobile, these objects are like really pretty negligible. And like I shouldn't give exact numbers because I actually don't know, but like we just haven't run into that. Like we haven't found that to be an issue. If it was an issue, what we would do is we'd probably implement some sort of windowing where like the only thing that we retain in memory is the thing that the user sees on the screen or something like that. But yeah, again, like we haven't, I mean, not to be dismissive, like that's definitely like a very real concern, but we haven't run into it yet. Good question. Yeah, up here.
So how easy is testing with this?
How easy is testing? That's a great question. We were just talking to some of the Seattle engineers who are here a little bit earlier today about testing with this. It's pretty easy. It's relatively easy to do integration testing, but doing unit testing is a bit tough. And testing user interfaces it's pretty tough to do, especially from the console and the command line. But we're working on that. That's definitely another thing that's on our roadmap. We want to make it like really, really easy to build tests. And what I think that's going to boil down to is like in the framework itself, you're going to have methods that like maybe they're stripped out for production, but you're going to have methods that you can call from in your tests that let you like peek into the internal state of things and check and make sure that everything is how it should be. So definitely on our roadmap, making that better. Another question up here, I think. Yeah. Oh yeah. Oh yeah. Go ahead.
Do you think this will reduce URL parameters or get URL parameters, eliminate them completely?
Good question.
Well, there's something like really cool about URL parameters in that you can bookmark them, right? So I think that like we're always going to want some kind of a routing system. But the question is, does that routing happen on the server or on the client or in JavaScript or in PHP or Rails? That's kind of where we open things up. The browsers like are naturally, like bookmarkability is a really cool thing about the web. So we don't want to remove that, but we want to just allow ways to do that in other paradigms and other languages. And so Instagram actually uses Backbone to do the routing. Like they kind of trim it to all the models, but they still use a Backbone router and then use that to inform what React views to render.
I see it as kind of orthogonal. Like they're two kind of separate concerns. Cool. Yeah, right here. Oh, sorry, right here.
Is there any security, concerns about this? For example, the owner function as a event handler is exposed to the presentation layer.
Okay.
So we cannot use the anonymous or kind of this kind of attaching. So is there any security, concern for?
In terms of events, the way that you're giving your component the function that should be invoked on some event is basically the same as you'd do with an event listener if you just did add event listener. So I think it works pretty much the same way that it works in JavaScript normally for events. I'm not sure I really follow that.
Because this you cannot attach a anonymous event handler there, so people can change the event handler.
Oh, I see.
Something else.
Yeah, so if they had a reference to this, the component instance, then they could say, oh, this dot props dot my callback equals something else, right? But you can pass an anonymous function there. So in our examples, we only showed this.props.onClick or whatever. But that is just a JavaScript function. So you can refer to any function. So that can be a function that's local inside your scope. It can be something that is just specific to your JavaScript file.
Necessary. If you are using the module pattern, you can create a private function.
Yep.
And you can use the attach event, not a click on click equals something.
Oh,
so they never can.
Great. Good question. So this doesn't actually use inline handlers. We should have called that out explicitly. Yeah. The syntax that you write looks like an on-click handler because it's quote unquote declarative. Like it's easy to write as a developer and oh, that goes here, right? But behind the scenes, what's actually happening is the node is given a unique identifier. And then at the top level, there's an add event listener call. And you can't touch that as a developer, right? That's the system attaches a top level listener. And no one can change that. That thing is just an event inside the system. And then when your node is clicked or invoked or moused over or something like that, the top level system dispatches to the node that had that ID, right? So we're not actually using inline handlers. And also, remember the thing that we output there, that is not actual DOM nodes. That when you saw less than div, that is actually just a JavaScript object that represents what a DOM node will eventually look like.
But how can you find the function, the event handler that describe this function to be used? How do you find it must be exposed to the function?
It's not exposed to users from the console or anything like that. It's not exposed. It's actually just internal to your component. But we should talk more later because I want to understand a bit better. Yeah. Cool. Yeah. Another question back there.
You guys distinguish between event phases based off of this question. So where are you catching this? Are you catching it on capture, on bubble?
Good question.
It kind of seems like a bounce.
Good question. There's for every native event callback like onClick, there's also an onClick capture. And so all of this is synthetically bubbled, right? Because we own the entire event system. We actually capture all the way down to the target node and then bubble all the way back up. And in doing so, we're able to do a lot of things that you can only do if you maintain that entire process. Like we can ensure that that happens in a very consistent way across all browsers for events like mouse enter, mouse leave, which don't even exist in most browsers except like IE or something. So we can actually roll our own events, and we have an event plugin system where you can define your own gestures and events, inject them into the system, and they automatically become available on all these.
But you guys are catching them on capture at the very top.
Yes.
And kind of usurping it at that moment and taking it over.
It depends. So on focus, you have to catch on capture in IE. Otherwise, you'll never get it on bubble. And then other events, it just makes sense just to catch them on the bubble phase.
So for those other events, do you let the natural event or the native event go all the way down and back up and bubble all the way back, or do you cancel it at the top and just let your synthetic event pass through? It seems like having both events processed.
That one, the second one.
We don't cancel them, we just ignore them, right? And we just let React know that a click occurred on this ID. We know where this ID is located in the virtual DOM and synthetically bubble it through our entire virtual document.
Yeah, we don't actually cancel them because if you think about it, if you rendered a link with React, just because you click the link doesn't mean, or just because the link was rendered with React doesn't mean clicking it shouldn't take you to the href, right? But what we do is we also we process the events ourselves. So we kind of just ignore the native events, and then we process through that hierarchy our React event. Yeah, good questions up here. Let's get a mic up here. Oh yeah, there's one.
What about continuous events like progress events?
Yeah,
are you able to capture those in their original state? And
we haven't.
Yeah, I don't think we've built any yet, but yeah, I imagine they would work kind of just the same way. I don't know. So you talk about like XHR events for like the on progress event for like file transfer?
Sure.
Yeah. So how do they work in the browser? How do they work in the browser?
It's an on progress event.
Yeah, on progress, and it gets invoked every single time there's progress. Yeah.
Is there a target node for them?
No.
Okay, so our event system is like it's DOM oriented. So if there's an event that occurs on a DOM node, we can easily capture that or trap it and then bubble it through our synthetic system. I don't know if that is really that relevant.
Yeah, that's just something that React would just like not do, and you do that in your application code.
Okay.
Yeah.
But maybe we should. I don't know.
But like an interesting thing you can do is like in your on progress event that you've subscribed to normally, you just say, hey, React.render component, and you say progress equals whatever the progress was passed in, and then you're done. Like you don't need to say, oh, set the width of my progress bar to be this times that. You just say render component this. It takes in a percentage and it knows how to do that, right? So yeah, so I basically any application events or any application logic, you just kind of use normal JavaScript to hook into the reactive system. If that makes sense, yeah. Cool. Another question over here? No? Yeah, one more.
Oh, one of the things I was kind of curious about was going back to that kind of example you showed within the code about like you had this, it was a counter and it was like bind +1, bind -1.
Yeah.
One of the things I was concerned about is like, say like you have a use case where you're changing the DOM and when the DOM reaches a certain state, such as like when you gave it that switch the title of the page or something like that, user inputs the field, press enter, the title of the page is X. So how easy is it to say, check for when title of the page has been switched to Facebook and then handle a specific event for a special binding, like when the bind is a specific value, how you write a React or whatever we're calling them, how do you have an event correlated to a specific binding? That's what I'm basically asking.
Yeah, so remember, we're not actually doing that imperative like, when this thing happens, respond in this certain way. What you would do is you would just say, if the title equals Facebook, then this thing goes, right? This code gets executed, or maybe my component looks this way when the title is Facebook. So like when you're writing things declaratively, it's a bit of a mind bender at first. You're like, wait, what do you mean what my component looks like at any point in time? I don't understand. But like once you do it, what you'll see is you never get to this point where you're like, okay, after that thing happens, then I need to do this. Because what you're describing is mutation. Yeah, so what you basically do is you pass all of the information that you need in your world, all your context information, into that render function, and then you just check the value of things, and then output something based on those values. So I don't know if that answers your question necessarily, but mutation is very, very different than this kind of declarative reconciliation. Yeah. I don't know if Jordan, if you have anything you want to add there. Yeah. Okay, cool. Cool. Yeah, question back there?
So you guys had mentioned that you have unique IDs for each of the DOM nodes.
Yeah.
How are you storing those, and what's the overhead of having a unique identifier for each node? Of the DOM,
Good question.
Whatever the browser already has.
I measured a significant consumption of memory as a result of it, but it does allow us to do a lot of other cool things that could potentially save memory. It allows us to be completely detached from the DOM because it's this like thing that's not really of consequence. It's this material world, and like we're in this very like logical abstract world. And when things happen in this material world, we just need that little ID on that DOM node, and we'll go over here to our virtual world and do whatever we want, and kind of like flush over the small changes. So to answer your question, some memory is consumed by creating these very long IDs. We just haven't invested a lot of time into making them shorter and making them consume less memory.
And how are they actually stored in the DOM? How do you look up that node again? Is it an actual ID or a class?
Oh yeah, yeah, ID. It's the actual ID on the DOM node.
So if you did any styles that were based on ID,
right, can't do that.
Right. So React is very much so geared at sharing code with people, right? And by putting an ID on our node and targeting that with the style, you're saying this is globally unique. And who can say that when you share code with other people? Who can say that like this property of this DOM node, nobody else is ever going to create a component that has that same ID? So like we're willing to give that up.
I know where you're going. There are other purposes for IDs, right? Like what about the for attribute?
Sure, but are you also creating like full GUIDs? Or
That's a great question. If you view source on facebook.com, you'll see what these things look like. It's the path in the render tree to that component from the React root. So what it'll look like is like brackets, 0, brackets 1, brackets, some texts, brackets something else. And it'll be this like very long thing. They're not globally unique, but they are unique to the page.
And don't freak out if they're really long. What I believe actually happens is that the browser, when you concatenate strings, I think it stores back references to other strings, because I did some performance experiments where I would continuously concatenate to something, and you would expect, like, if you're storing each version, you'd expect the memory just to like blow up, and it didn't. Yeah. So I'm guessing that what's happening there is that each of these strings are substrings of other strings, and so the browsers do something smart there to optimize that.
But something really cool happens when you completely abstract yourself off of the DOM. So hopefully I'll blow some of your minds right now. The fact that we're rendering down to the DOM, the actual like browser DOM, is like just an implementation detail. So what we've already built internally, this guy Sebastian, immediately as soon as he saw this, he's like, I'm going to use this to render graphs in Canvas and SVG. And all he did was make one component, one change, that instead of rendering down to React Native components, which is divs and spans, which are strings of markup, it renders down to like Canvas painting calls. And as your virtual DOM, as your virtual view updates, more rendering commands are output to your canvas, and your drawing gets updated. And then what Jordan did is he's like, all right, I'm going to take the exact same code that renders an action button as divs and spans in the document, and I'm going to turn it into a native component in iOS. So we use Titanium.js to basically take this representation of JavaScript, which is the same code that we would run in the browser, and turn that into like rendered native components on iOS using JavaScript Core Bridge, which is pretty nuts. We don't talk about that too widely yet because we haven't like done a ton of stuff yet. But like you can envision building a component with your like custom DSL and then rendering it down to whatever you want, be it WebGL or Canvas or SVG or DOM. And then as your developers use your components, they're just like, oh, I need a type ahead here. They don't really care about where that type ahead's used, or as the component author, you don't look at that. You just say, oh, this is a type ahead. And then it renders however it wants based on the platform.
Because we control that environment completely, all the same bubbling patterns that you're used to, like they just work in no matter how regardless of how you're rendering them. Even if you're rendering down to iOS views, you still get like this capture bubble phase. You still can like prevent the propagation of that event to higher levels. And the same paradigms that you're used to composing things in the web, you can kind of bring those over to other environments.
Yeah, so I don't know if we should have talked about that in detail yet, but like that's what we're really excited about. Like that shit's cool. Yeah, another question back there? Anyone? Cool. What time do we have till? Can we just stay here and like hang out all night?
Let's maybe wrap it up and
we'll have
just
to go. About 10 more minutes. So any more questions? We're happy to just like hang out and chat too. I feel like no one's gotten up for a really long time. I would have gotten like 4 beers by now if I was hanging out. Yeah, there you go. You still got one. Cool. Yeah, there you go. I should have left this up on this slide. This slide is more interesting, but really, we encourage everybody to check this stuff out. We put it all up on GitHub. Like all of the docs are there, and yeah, it's all right there. Yeah, go ahead.
Is it already available? The To Do MVC, is it out there?
Yeah, To Do MVC was like with the launch from day one. Yeah, about 3 weeks ago, I think we launched. Yeah, we're up to 0.3.2. But we're going to be probably rolling out 0.4 either next week or the following week. Not really. It's like a different kind of approach. But like, in order to like get people's attention, you have to be like, oh look, another MVC. Yeah, we're just the W in Angular's MVW. Cool. Great. Well, thanks again, everyone, for coming out. We're going to be hanging out for a while, so if you have more questions you want to ask that you didn't want to ask in front of everyone, feel free to come grab us. Thanks again.
Thanks, Tom, and thanks, Jordan. We still have some food and